Hello and welcome to Wednesday's edition of Cracking the Cryptic on another blisteringly hot day here in the UK. For those of you who got cross with my use of Fahrenheit yesterday, it's at least 292 Kelvin here in England, so pretty warm. Now, some of you noticed that I was savouring the finale to yesterday's puzzle rather, and you're right, sometimes I do like to do things with delayed gratification, so let me just do that now. There we go. Fantastic sort of Tantric Sudoku, if you like. Now, what have we got for you today? Well, a puzzle that's come very highly recommended, and it's called Killer with Sandwiches, and it's by Joe Wavrin. And this puzzle, which, well, I mean, it is a killer sandwich hybrid, I am looking forward to trying mightily because I have not done a sandwich Sudoku for ages. So it ought to be fine. And yeah, I'll read you the rules in just a second. A couple of things to mention first. On the channel earlier on today, we released a Spartacus's How I Set Sudoku video. So he goes through how he set his Wheel of Arrows puzzle. I definitely recommend, if you have any interest in setting Sudoku at all, that video is absolutely splendid. And that's already out. And then, of course, yesterday we released our Hitchhiker's Guide to the Galaxy Sudoku Hunt over on Patreon. And we have had an astonishing response, literally astonishing. I mean, so many of you have solved it. And I didn't think the last puzzle in particular was terribly easy, but I'm going to say very well done to the following. Well done to Tom Walker, who was the first correct entry we received. Jan Gazelius, Nathan Gilbert, Lucas Stefanich, Ethan Strumwasser. Oh, this one has a rune in the... I'll do my best with this. Hlynor Poor Jensen, maybe. Sorry if I got that wrong. Peyton Lee, Dvorak42, Cone de Vilt, David Berardo, RJ and Henry Powers, Brendan Blackwell, Nicholas Allendorf, Alfredo Gliotti, RJ White, Zach Thierman, Tim Dorr, Nell Gwynn, Lemetrop, Kevin Thompson, Monday Dynamo, Talayla Snow, Tavin, I think it might be Tevin, I'm not sure. Alan Altman, Aaron Spiller, Ben Needham, Dance1211, Joe Chang, John Spithiagarnis, Phoebe Stanton, John Tamplin and Jeanette Allen, Christy Klingert and Patrick Sample, Dan Glickman, Dennis Leon Zhang, Pankaj Kansal, Harry Dorsey, Nick Smirnoff, AJ Gosling, Chris and Peter Mears, David Rankst Clamage and Jessica Subtitle Shaham, Kelvin Graham, oh good luck with your med school application Kelvin, Morris Kohler, Patrick Nisi, Sarah Turvia, Flintheart Glomgold, I hope that name is real, Claire Matthews, John Rice and Scott Nakamura. So many of you have done very well and got through that. Congratulations. Now, if you think your name should have been read out because you have sent in an answer, double check the answer you sent and whether it sort of obeyed all instructions. In particular, did it highlight the answer and the question? So yeah, if you want to know what all the fuss is about and why I'm reading all these names, do join us on Patreon. We do think it's quite good value, and we're actually not that far away from 5,000 patrons, and if we get there, we'll be releasing a murder mystery Sudoku, that is, well, Sudoku Hunt, I should say, which is rather marvellous. So that's to come, we hope. Now, what are the rules of Joe Wavrin's puzzle? Let me read them to you. We have got normal Sudoku rules apply. In cages, digits must sum to the small clue in the top left corner of the cage. So fairly straightforwardly, those 3 squares sum to 8, those 2 squares sum to 14, etc. Clues outside the grid give the sum of the digits sandwiched between the 1 and the 9 in that row or column. So how does sandwich Sudoku work? Well, it's rather marvellous. So basically, look at this column. Let's imagine we put a 9 here, 9 here, and a 1 here. Now we know those 3 cells have to sum up to 12. So that's how it works. It's fairly simple rule set, but it does lead to some marvellous logic. And we've been doing sandwiches on the channel for years, but we haven't done, well, at least I've not done one for ages. So do have a go. The way to play is to click the link under the video as usual. Now I get to play. Let's get cracking. Now, do we do killer clues or sandwich clues first? Well, I'm going to note there's a 1 in this 8 cage because 1s and 9s are particularly important. In fact, let's actually think further about a 1. I can't put a 1 in those cages at the top, look. They're too big to have a 1 in them. So the 1 in box 2 has got to be there, and the 1 in box 8 has got to be there. Which, okay, doesn't seem to do anything. So maybe we look at the sandwich clues. Now, the 27 clue is by far the biggest, and 27 is an interesting number from a sandwich perspective. Let me explain why. Let's put a 1 in here, just for the sake of exposition. How far away would the 9 be in this row, as a minimum? How many cells would it have to be away? Well, we could make this square an 8, this a 7, this a 6, this a 5. If you add up those digits, you only get to 26. So you'd still have to have another cell here that would have to be inside the sandwich. So the 9 would have to be at least here, which is quite a long way away. Now the key, once you realise that there must be at least a 5-cell sandwich, is to realise that you can never now, let me show you what you can never do. You can never have a 1 or a 9 in any of these 3 squares, because if you try and do it, the puzzle will break. A 5-cell sandwich, 1, 2, 3, 4, 5, you'd have to put the 1 out of the grid, where it can't live. So don't do that. So what we can do, actually, we can definitely delete 1 from this square. These 3 squares cannot be 1s and 9s, and this is my big tip for Sandwich Sudoku. Turn the cells that can't be 1s and 9s green. You can use a different colour if you want, but it will be wrong if you do use a different colour. You should definitely use green, and then these squares, therefore, we know cannot be 1s and 9s. Now, that, of course, doesn't actually seem to do anything, but it was very important, I'm sure. Now, the only other clue I can see from a sandwich perspective that looks interesting is the 22 clue. Because 22, let's think about how big this sandwich must be. Well, 8 plus 7 plus 6 is only 21, so we must be looking at a 4-cell sandwich. So if we try and put a 9 or a 1 in this square, we've broken the puzzle again. 8, 7, 6, whatever we've used to fill this square, but the 1 will have to be off the edge of the grid where it won't be able to go. So this square can also be turned green. So now we know in this domino there's got to be a 1 or a 9. Therefore, I'll highlight those in purple. Purple means you've got to put a 1 or a 9 in the purple squares. So those can be purple. We can't put a 9 in there, but we could put a 1 in there. So, in fact, actually, no, I was about to get excited about the 8 and the 7 dominoes because they add to 15, which is a relatively low total, but they aren't low enough to conclude there has to be a 1 in them, because we could fill this with 2, 3, 4, 6, for example, and that wouldn't have a 1 in it, and it would add up to the right number. So that allows us to exclaim bobbins and move on. Right, where do we look next then? Have I underused the 1s that I've got in these positions? Probably is the answer. So, how do we make better use of these? The answer, my friend, is blowing in the wind at the moment. What little wind there is, I've got no clue how to do that. Actually, this is really strange now. I'm now getting the fear because I can't actually see what to do. No, there doesn't. I was about to say, does there need to be a 9 in this foursome? But there doesn't, because these add up to 26. 8 plus 7 plus 6 plus 5 is 26. So that's put paid to that. 14. Wondering about the 14 and the 15 clue. Oh, how strange. Right, okay. So, hang on, is this right? I'm not sure it is right, because if this is right, I've never seen it before in a Sandwich Sudoku, and that makes me think I've misunderstood what's going on. No, that is right. That's really, really... I mean, it's beautiful, but I have never... I'm amazed this isn't some sort of standard technique, because it's incredibly clever. Right, this 14 total here is either 6-8 or it's 5-9. Now I want to look at whether it can be 6-8, especially in the context of the sandwich, because how could this be part of a sandwich? So let's imagine that this was inside the sandwich. Well, these two squares are adding up to 14, so we'd have to add a 1 to them inside the sandwich, which would then have to be surrounded by a 1 and a 9 to make to make the crusts of the sandwich. Well, that's nonsense. We can't do that. We can't put two 1s in the row. So what that tells us is that this is outside the sandwich. But now how do you make 15 work? You can't make it work, because you can't put the 1s and the 9s here. You can't make that square equal 15. And if you try and put the 1s and the 9s here and have this as a little 2-cell sandwich, you might think you can do it, but you can't, because the 8 and the 9 have gone from the row. The 9's in the crust of the sandwich and the 8's in here. So it's impossible. So that is not 6 and 8. That is absolutely incredible. That really is. That I'm astonished. I must be forgetting, I think. But if that is original logic, Joe Wavrin, take a bow immediately, even at this early point, because that is it's incredibly clever. Right, so, but this is brilliant, because now, this is not blue anymore. Well, now we know that this is 5-9, and that's gorgeous, because the 12 cage now is not 5-7 or 3-9, that's 4-8. Okay, now what's that doing to these positions here? Probably something profound, which we're going to have to spot. So, I'm sure it's doing something profound, although it's not obvious to me what, I have to say. Oh dear. So do we know whether this is 1-2-5 or 1-3-4? If it's 1-2-5, you get a 5 here, you get 5s in one of those three squares, all of which look possible. If it's 1-3-4, all you'd learn is that there has to be a 4 over here, which again, I mean, looks possible. I don't think you'll be able to do the same trick with the 14 and the 13. Although I'm hesitating as I say that, because I haven't actually worked it out. It just feels like there's too much flexibility in the 13 clue. Actually, it's worth checking this, because I don't think 6-7 work. If this works again, this will be absolutely stunning. Right, 6-7 in the 13 clue. Again, we do have the same logic, which says that this cage can never be in the sandwich, because it would have to be accompanied with a 1 in order to make the sandwich total. So what we know is that in this row, if this doesn't include the 9, the sandwich total would have to be, the 1 and the 9 would have to be in those two positions. So we'd be trying to make this domino add up to 14, which we can't do with 6-7, because 6-8 wouldn't be available, and 5-9 wouldn't be available because 9's in the crust. Now, no, it doesn't work. Oh, this is so clever. It's just stupid. I mean, it's just, which I realise is something. It's a slightly strange way of expressing it, but it's just, it's making me feel stupid. Now, because now, of course, if we have 1-9 in the blue squares, we can't put 5-9 in here. And this time we can't use 6-8 because we've used the 8 in the 13 cage. So because in the options that don't use 9 in the 13 cage, you always have a 6 or an 8 in the 13 cage, it just doesn't work. And when things don't work and they're that clever, you have to take your hat off. So this is 4-9 now. And now I can see straight away, look, that there's going to have to be a 9 in one of those squares. Because if there isn't, you've got double 9 in these squares, and you've got to put 9 in an 8 cage, where, let me tell you, it cannot live. So, That means there is a 9 in one of those two squares. I'm not actually sure that that is terribly informative. It's quite interesting, but it doesn't seem to do anything. We still... No, I still don't think we know more about this, do we? The 9 cage can't be 1-8 or 4-5, so that's 2-7 or 3-6. None of which appear up there. Is that right? So if this is 3-6, that's a 3-6 domino. If this is 2-7, that's a 2-7 domino. Oh, simpler than that. Right, I see what's happening. What we've managed to do now is eliminate 5 from this domino. 5 is definitely not in the 9 cage, so 5 is not in these 3 squares. So, how could the 8 cage be 1, 2, 5? It can't be, because that's going to put 5, 5. You're going to need to put a 5 in one of those. You can't. So there we go. We've got some logic. 1, 3, 4 go in here. That fixes this square as a 4. This is a 9. This is a 9. This is a 5. And okay, does it do anything more? Maybe it plonks 8, look, into this domino. Yeah, oh, this is clever, actually. Now we can do the same trick and ask whether this can be 3, 6. If this is 3, 6, you've got to put a 3 in one of those squares, and there isn't a 3 there. So this can't be 3, 6. That's got to be 2, 7, which means this is 2, 7. Now this column is all but complete. I mean, we've got no clue where these 5 digits actually go in terms of their position, but we do know that they have very limited choices. So this is a 6, 8 pair, which means these squares have got to be 1, 3, 5, I think. Get rid of the 1. These squares are 2, 6, 7, just to complete the column. These squares are 5, 8, 9 to complete the box. These squares are 1, 3 and something, 1, 3, 6, I think. Right, okay, so we've got some progress. We have got digits in the grid and progress and some rather clever logic. So that's not 1, that's not 9, because we've made these green, and we should use our green to the maximum. Okay, so I can see, I'm just going to tidy up these pencil marks, but then I think what I want to do is to look at these 2 rows and try and use my 9s to see where the 1s are going to be able to live. So let's tidy up this. That's got to be 8, 3 or 4. Don't think there's any restriction on that. It would be very nice if this 7 cage was a 3, 4 cage, because it would give us this one. This one has got to be 14, so we're looking at 5, 9 or 6. Which is interesting, but probably not useful enough. Looks like we've been given a very, very carefully selected number of sandwich clues, doesn't it? So, right, well, let's look at row 1 then. So we've got a 9 here, so a 15 sandwich clue is definitely at least 2 cells. And in fact, on this line, look, you can see we can't make this domino add up to 15, so it's at least 3 cells going this way, so all of those turn green. And a 4-cell sandwich. Ah, right, okay. That's interesting. You can't do that, actually. You can't put the 1 here. Because if you do, you can make 4 cells, not using a 1, add up to 15, but not if you include a 5. The only way of doing it, I think, is 2, 3, 4, 6. So that's a strange thing. That's sort of a weirdity we've discovered. So that means, what does that mean? It means this square here is not a 1. So that must be green. And the 1, we still don't know. It's in one of 2 places. It's not here. Now, if it was here, this square would have limited values now. Oh, 7 or 4. Okay. Okay, maybe this is not what we're meant to do. Let's check row 9. We've got 14 here. Again, that's got to be at least, in fact, it's got to be at least 3 cells if we come in this direction, because we're only picking up a 4 as the first digit. So we can't make this square equal to 10. So all of those turn green. And in this direction, same logic again, in fact, because even if we put 5 here, which is the highest digit we could put in, we couldn't then put 9 here in the sandwich without it clashing. So those squares are all green as well, which is almost interesting in terms of where ones have to go in these rows, isn't it? So ones have to be in 2 of those 4 cells. That feels like it might matter. Oh look, yeah, no, that would be massive if I can get a 1 in one of these 2 squares. It's going to fix these 4 squares for me. So the only way that that's not true is if you've got 1s in those 2 positions, which I'll put. Well, that can't. Hang on, 1's in those 2 positions. That definitely can't be. Oh! Ah! Got it. Right. Good grief. Okay. So what we should have done is when we realised that this square and this square are green and cannot be 1s and 9s, we can adjust our 22 column. We can add green to it. And the power of green is going to be important because can this square or this square now be a 1 or a 9? And the answer is no, because we know we need a 4-cell sandwich. Now, previously, we'd been, whoopsie, I didn't mean to do that. Previously, we've been thinking that if, for example, we had a 1 here, we could have a 4-cell sandwich because we could put the 9 here. Well, now we can't, because this has turned green and this has turned green because of the 15 and the 14 clues. So you can't put 1s and 9s in either of those 2 squares. Now, that's actually going to tidy this pencil mark as well, which means this square's got to be high. So it's done a bit of damage to this cage, but I don't think this is the important thing. Now, watch what's happened in these, in row 1 and row 9. In each of these rows, we've got a situation where the 1 is locked into exactly 2 positions. You can see exactly 2 positions. So the question I'm interested in is it possible for me to avoid putting a 1 in either of these positions? If I know that one of these positions is a 1, these 4 squares become absolutely beautiful. So the only way these are not 1s is if both of these are 1s. And if both of these are 1s, I need to put a 1 in there where I cannot put it. Ergo, there is a 1 in one of those 2 squares. Ergo, there's no 1 in this 15 cage. And therefore, well, we just did this. In fact, it was up here. We were looking at whether... Yeah, I was looking at whether this could be a 1. But this has got to be 2, 3, 4, and 6. So... now this 7 cage, the only way that 2 of these 4 digits add up to 7 is if they are 3, 4, which means this is 2, 6. That does add up to 8. All of these squares now are most certainly not 1s and 9s. They all turn green. I've got a 3, 4 pair now in row 5. Which, oh, hang on, I've got the secret. Right, we can use the secret. Ah, this is just stunning. It's just stunning. Right, let's look at this row. So, if we correctly completed this row, what digits would be in it? Well, the answer to that is not. It's not difficult. It would contain the digits 1 to 9 once each. If you add up the digits 1 to 9, you get 45. So this row adds to 45. But we know that there's a sandwich somewhere in it. We don't know where it is, but somewhere, let's just say it's those squares, adds up to 27. Then we know around the edge of the sandwich we have to have a 1 and a 9. Well, 1 and 9 add up to 10. So far we've got 37, which means the cells outside the sandwich, which definitely include this little green square, have to add up to 45 minus 37 is 8. How could this be a 4? The answer is it cannot be a 4, because then I'm going to have to put cells that sum to 4 outside the sandwich with the 4 that I've put in here. Well, I can't put a single 4 in because that's definitely going to clash. So I'm going to have to put 2 digits that add to 4. Well, I can't put double 2, that breaks the rules of Sudoku, and I can't put 1 and 3 because by the rules of sandwich Sudoku, the 1 needs to be in the crust, and that was in the 10 that we counted, the 1 plus the 9. So I can't repeat the 1, therefore this cannot be a 4. And that's a 3, that's a 4, that's a 4, and we are off and running again. Maybe. So now we need to put 5 more. Ooh. Oh, it's beautiful again. Well, now we've got to put 5 more outside the sandwich to go along with our 3, because we know that there's 8 cells totaling 8 altogether that are outside the sandwich. Well, we could never have the option of putting 1 plus 4 outside the sandwich, because 1 is obviously part of the sandwich crust. We can't put 2 and 3 outside the sandwich because that would repeat the 3. So the only way we can construct cells totaling 8 is with a 5, which means there is either a 5 here or there is a 5 here in this row. And I don't know which is correct, but I do know therefore this square is definitely not a 5. That is an 8. Which seems to give us a 9 here and a 5 here by the power of maths. And this is a 5. Oh, and in fact, that bounces back. Look, we play ping pong with 5s, and now we know that this has got to be the 5. And we know this is therefore outside the sandwich. And therefore, this square is going to have to be a 1 or a 9. And we know we need a 5-cell sandwich, so this square is also therefore green, and therefore this square is a 1 or a 9. And we can stare at the puzzle again. This is this was a 3-4 pair, so this is 8. So that's a 2. And now, where shall we look next? Have we learnt enough to know what's going on in some of these other rows and columns? I haven't got a clue is the answer. I've got a 4-8 pair there by Sudoku, look. Which, I'm not sure if that does anything. Yeah, let's actually use Sudoku to solve our Sudoku. So 3 in this box is now down here in one of those 3 squares, so it's definitely not here. So that's a 1, that's a 3. Yeah, yes, lovely. Now think about the 1. Where does the 1 go in this box? And we still don't know. Well, we do know now actually, because we know it's in one of those 3 positions by Sudoku. Well, it can't be inside the sandwich, so it must be here, which makes that square a 9. Okay. Which means, what do we do now? That's the next question. So there must be, you see, there must be a 1 up here, but we don't actually know anything about row 4, so this 1 being up here is not terribly helpful. I'm wondering about whether I should continue the colouring. I think I will for a bit longer. All of these squares are obviously all green. This becomes purple. All of these become purple. This is green. I've got this one as, oh, that is green from our 22 clue. Okay, that's reasonable. So 9 now, look, has to, oh, look. Whoa, yeah, okay, where does 9 go in box 6? It's not here because of the power of green, and it's not in a 9 cage because you can't put 0 there. So that's a 9. and therefore that becomes purple. Now all of these turn green, which might matter. Oh, it does matter. This is right. Now I've got a 1 here. Well, I'm not sure if it's the 1 or the 9 that matters, but look, this square is now not a 1. And if that square is not a 1, where do we put the 1 in row 9? It's got to go here. That means this isn't 1, so where do we put the 1 in row 1? It's got to go here. There's a 1 in one of these two squares. Can we do better than that? Oh yeah, look, what we can do, this square can't be a 1 because of the 12 clue. Sorry, I should have seen that, but I didn't. This 12 clue must be at least 2 cells. So those, in fact, those 3 squares can all be turned green. This square is a 1. Now by Sudoku, this square is a 1, this square is a 1, and we are cooking with gas. Have I done... Oh, I see, I've done 7 ones. Look, it's just these ones that are left. That's definitely not a 1. So... Right, now we can ask where 2 goes in box 4, because 2 is not here by the power of Sudoku, and is definitely not there because I can't put 10 into that square. So 2 goes here, that becomes a 6. These 2 squares have got to be presumably 6 and 7. Oh, I see what's going to happen here. Now can this square be a 6? No, because that's going to double the 6, which won't work. So that's a 7. That's a 5 to make it add up to 12. This square's a 6. That's a 7. That's a 6 by Sudoku. These 2 squares are 2 and 6, I think. Sounds like an old price of something. Those 2 squares are 3 and 7. Now we've got a 9 cage here. So that means this square is 2 or 6 again. Which doesn't actually seem to... Probably missing something there. I can't see how to do that. This square must be green. That square's green. We've not put 9 into... Oh! Let's look at this 12 cage. It's not 9. It's not, so it's not 3, 9. It's not 4, 8, because that will break this square. So that's a 5, 7 pair. Doesn't actually seem to do very much. It locks a 7 into one of those squares. Ah, here we go. Yeah, okay. So we can see there's no 7 in any of those 6 squares. So there must be a 7 in this domino, but there's a 7 here. Look, so that's a 7. There's a 7 at the top of box 1. Can we tidy this up? I'm not sure. Oh, yeah, we can actually. Yes. Because of this 4. So this domino is adding up to 7 to make our 14 sandwich total. Well, if we put 3 in here, you have to put 4 there, and that won't work. So that must be 5, this must be 2, and these 2 squares lose their 5 possibility. These squares have become 3, 6, and 8. Whoopsie. 3, 6, and 8 means that square's a 2, that's a 7, that's a 3, that's not 3 anymore. Okay. Now look here. I haven't filled in the options for this little square. And we now know this is the 15 sum, so this square has to be the complement of this square in adding this domino to 10. So this is 4 or 7. Not sure. This row, that's got to be green, because of course we've got our 1 and our 9. These 3 squares all can turn purple. So 9s, maybe I've not looked at 9s enough. Although they don't seem to actually do anything. That square's purple, that square's got to be green, that square's got to be purple. That square's got to be green. Those have both got to be green. Those have both got to be green. Well, I'm trying to tidy this up, but I'm still not seeing anything good. So many of these rows and columns, I know nothing about the sandwich totals. It's not that surprising. So, what have I not used? I've used the 14 clue. I've tried to use the 15 clue. I've finished the 12 clue. I've all but finished the 27 clue. I've not used the 22 clue. I don't really want to use the 22 clue. Maybe the outies are going to be more fruitful than trying to work out how on earth we make the sandwich work. So the outies, we're going to have 22 in the middle of a sandwich, surrounded by 1 and 9, which is 32, which we deduct from 45 to get 13. Right, as something, that square is not an 8, because if that's an 8, how do we make the outies add up to 13? You can't. If you try and put the 4 with it, the other outie will have to be a 1, and that will repeat the 1 in the column. And obviously if we go with a 7, that's just breaking the total altogether. And we mustn't break maths in order to do the puzzle. Whoa, 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 whoa. I just want to make that one a 6. Which means those two are not 6. That's lovely. That gets me a 6 and a 2. 2 now has to be in those squares. Look at the power of Sudoku now. 2 has to be in one of, yes, 2 has to be in one of these 3 squares, and it's not here, and it's not here. So 2 goes into the grid in that position. How many 2s have we done? Lots. This 2 is giving me a 2 and a 7. I don't know how long that's been sitting there, but it's probably a while. 7 and a 5 go in there. 5 has got to be exactly here. This column now needs 7, 8, and 9. So this square's an 8 or a 9. This is a 7, 8, or a 9. That's not 9 because 9 is not available in green squares. So, we must be getting, I think we're closing in, aren't we? Slowly but surely. 8, look. 8 is in these dominoes. So that means in column 7, where does the 8 go? It must be go in one of... Oh, this is gorgeous. Absolutely gorgeous again. 8 is in one of these squares. Now 8's ruled out of all 6 of those squares. So 8 must be in one of those 2 squares in row 1. Well, it's not there because of that 8. So that becomes an 8. That becomes a 9. That becomes a 7. That fixes the 7 and the 2 and the 2 over here. That doesn't seem to fix this column. We need 3. Oh, no, it doesn't. 3. Oh, that must be 3 or 4 because somehow the 8's over here, isn't it? So 3, 4, no. We're coming back to the 22, are we? Oh! Yes, yes, well, let's come back to the 22 because can this square be an 8? And the answer is no, because if this square is an 8, is it inside or outside the sandwich? It's going to be outside the sandwich because it's next to a green square. So those two would be outside the sandwich, and we've already thought about this when we tried to put the 8 down here. You cannot put the 8 outside the sandwich in this column once it has to accompany a 4 or a 7. So that's not the 8, which means that must be the 8, I think. Therefore that's an 8 and that's a 4. Which probably makes a difference. Let's check this row. Oh, you rotten thing. 3s and 9s, I think, have got to go in those squares. Can't see if we can do that. 8 must turn green. Ah, so in this column, we now know where the 9 goes. Because the 1's down here and we've got a 22 gap, the 9 must go into that square, which turns it purple. Gives us a 9 here by Sudoku. This square's now a 3. That square turns purple. These two turn, well, all 3 of those turn green. That turns green as well. This 3 is doing damage at the bottom of the grid with 3s and 8s and 8s and 4s, and that square's therefore available. 4, that gives us a 7. Check the... Now look what's happened in this column. And the answer is it is resolved because we've now got 13 outside the sandwich, which is exactly how many we need. So we now know that the 1 must go there. That just gives us a 1 here and a 3 here. And, well, 3 in one of those 2 squares. Now this box needs 3 and 4, and there's a 4 here, so we can keep going. 4s, 3s, 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 and 6s get done. We need a 6 and a 5 in that box. We need a 9 in this column. Turn it green. Turn it purple on the way through. Oh, that's purple. Look, I could have made that purple ages ago. Keep missing my purples. All of these are purples. I think I've done all my purples now, so that should be just a 4. This column, how am I going to do this with alacrity? That's going to be that, isn't it? This is going to be an 8. That fixes the 8 and the 6. Now, hopefully that's a 6. It does look good. So all of these turn green in order to preserve our chromatic palette, and I think we can click tick. Yes, that's a lovely puzzle. Really is a lovely puzzle. Joe Wavrin, take a bow. And this stuff we did at the start with the 15 and the 14 cage and the 15 clue is just, it's really, really clever. It really is. And I've not seen it before. Maybe it's because you don't tend to see Sandwich Sudoku married up with Killer Sudoku, so maybe it is original logic. In which case it's stunning. I enjoyed it, whether it's original or not, but if it is original, then that is incredibly impressive. So, thanks for watching. I hope you enjoyed that. I hope you had a go and enjoyed solving the puzzle, and we'll be back later with another edition of Cracking the Cryptic.